Let's solve this problem. There are two thin concentric spherical shells of radii A and B, where B is greater than A, carry charges Q and big Q respectively. B is greater than A, which means that B is the radius of the bigger shell and A is the radius of the smaller shell, inner shell. This picture is the cross section. Okay, so we have to find out the electric field at a point which lies inside the smaller inner shell. That is, it lies between 0 and A, means point X lies inside the smaller shell. And then in the second case, X point lies between A and B, which means it lies somewhere between the inner shell and the outer shell. Okay, so somewhere at this point. And the third case, we have to find X is greater than B and then infinity, the point somewhere outside these two shells. So for this, we are going to use Gauss law. So let's do the first one, where X lies inside the inner shell, smaller shell. So suppose this is X. I'm going to choose a Gaussian surface. Um, this is the radius of the Gaussian surface. That's X. And now we have to write Gaussian formula, Gauss law, that is E dot ds equals q enclosed divided by epsilon naught. Here E goes radially outwards, so E dot ds will become a E and ds is a 4 pi x squared. That's the surface area of the Gaussian surface, which is equal to q enclosed divided by epsilon 0. But here, if you observe inside the shell, there is no charge, so q enclosed is a 0, which says that E equals 0 in the case of first one. Now, second case, X lies between A and B, between the shells. Now, once again, write Gauss law, E dot ds equals q enclosed divided by epsilon 0. Here I'm going to draw the Gaussian surface from this point. This is actually the Gaussian surface of radius x. And now I have to write E ds is 4 pi x squared is equal to q enclosed. Enclosed is the charge enclosed by the Gaussian surface, and it is small q, because that is the charge on the inner shell, divided by epsilon 0. So which means E equals q by epsilon 0 and 1 divided by 4 pi x squared. This is for the second case. Now for the third one, the point X lies outside the two surfaces, so I have to draw the Gaussian surface like this, and the radius of the Gaussian surface is once again X. So let's write the Gauss law once again. A dot ds equals q enclosed divided by epsilon 0. But here E dot ds, E dot ds is 4 pi x squared here. The Q enclosed is charge Q in the inner shell plus the charge Q on the outer shell, Q divided by epsilon 0. So E will become Q plus Q divided by epsilon naught times 1 by 4 pi x squared. That's all. Thank you.